Hi, today we will make this abstract particle simulation in Blender. We start by distributing particles on the mesh. Then we add motion to them, calculate their normalized age for many use cases, set up the rest of the scene, add materials to them, render the scene, and do some final touches in compositing. So let's start. Here I have imported this humanoid mesh from 𝒚𝒐𝒎𝒆𝒏𝒕. To make the simulation, I head over to Geometry Node's workspace. I have reordered the workspace to have Geometry Editor, Timeline, 3D View, Spreadsheet and Properties panel. Make a new Geometry Nodes modifier for the human mesh, and I call it Particle Simulation. This input node represents our input geometry and this output node gives us the final geometry. To distribute particles, or in this case points, I hit Shift A and add Distribute Points on Faces node. Increase the density. To see these points clearly, I add a Set Point Radius node and decrease the individual point size. Increase the density a bit more. I want to see the initial human mesh along with this point, so I add a join geometry node and plug our points and the input geometry. Plug its output into group output. You can do the same by holding Shift Ctrl and right click drag from one to the other. Then Shift Alt click to plug it into group output. You can also hit Shift Ctrl click to get a viewer node for visual debugging purposes. I delete it for now. I want to limit the points distribution to certain parts of the mesh by using Vertex Group. First, I disable the Geometry Node modifier. Switch to Weight Paint mode and select Mesh Data tab from Properties. Once we start painting, it will automatically create a Vertex Group for us. I undo this painting and start painting on the areas I want the particles to emit. I can always come back and change this later, so no need to be perfect. Use the F key to change the brush size. I am happy with this for now. I rename the vertex group to 1. That way I can remember it easily. I come back to the Geometry Nodes workspace and enable the modifier. To bring the vertex group into the setup, I add Name attribute node. Here you can either type the vertex group name or find it from here. To view this, I add a viewer node selecting our initial mesh and then click here to view the attribute. Here is our vertex group as a black and white mass. I plug this into the selection socket of the distribute points node. This will distribute points only on those areas. I add more points. To make the simulation, I make some space between these nodes. Then I add simulation zone to the setup. Plug the input and output here. Basically, the simulation zone runs everything inside it in a loop. To demonstrate this, I add a set position node to the setup and add a tiny set offset. Now when I play the animation, the particles are moving 0.02 meters on the Z axis every frame. But I want to keep emitting particles every frame. For that, I can use the join geometry node we used earlier. I add a join geometry after the simulation input. Then I disconnect the points from here and plug it here. This way, it keeps adding a set of points every frame to the simulation. Like that. Right now, it has this trailing motion because every set of points has the same starting points. I can change this by simply changing the distribution of the points in every frame. This seed value will do that for me. To automatically change this every frame, I search for Scene Time node. This gives us the current time in the animation by seconds and frames. I plug the frame into seed input. Now this will change the distribution every frame, giving us a random look to the particles. Let's change the motion of the points. I want them to go up and back, but it is very linear at the moment. I want some noise to it, so add a noise texture. The best way to view this is probably with our initial geometry. I do this to get a sense of the noise scale. I disable the normalize option and decrease the scale. Disabling the normalize gives us a negative values in some areas, which helps to move the points in both positive and negative directions. I adjust these parameters. Since I want vector values, instead of factor output, I use color output, which I can use as XYZ directions. I plug it to offset. Delete the viewer node, and you can see it is way too much. We need to reduce its strength. To increase or decrease the strength of vector values, I use vector math scale node. This will multiply all three vectors by this scale value. I reduce it to 0.1, and you can see we have a very random noise motion to the points. I follow this with a vector math add node and add that upward and backward motion we had earlier. Right now they are following a static noise path. I want this noise to change over time, so I change the texture to 4D, which gives me this 𝒂𝒐𝒂. And just like before, I use the scene time node to automate this. This time I use the seconds output. It changes the noise faster than I want. So I add a multiply math node in between and multiply this by 0.1. It will reduce the speed by 10 times. I like this noise motion, but I like to have another layer to it. I can do it here, but I like to do it separately with another set position node. By the way, Shift D to duplicate nodes. I duplicate these 4 nodes and plug them to here. And in this second layer of noise, I increase the scale. This will add a bit of jittery movement to the points. Also, I reduce its strength. Play with the values to find the desired look. Now, if you look at the points amount in the spreadsheet, you can see it quickly increases to a very high number. I don't want the points to last the entire length of the animation, so to delete the points, first I need to calculate the age of the points. It's a very simple setup that I have done quite a few times before. So make some space here and follow my steps. I add a store attribute node. I call the attribute age. Since I'm calculating age by the frames, I set the type to integer. Then I add named attribute node to read the attribute we just stored. If you don't see it here, just copy paste the name. Simulation needs to be refreshed to see it in the menu. And for every frame, I add 1 to the age and store it as the new age. This will calculate the age of each points. Now to delete the points, I add delete geometry node, duplicate the age node, and check whether the age is greater than or equal to, let's say, 40. Plug the result into selection. And now when I play, every time a point age 40 frames, it gets deleted. I reduce it to 10 so you can see it clearly. But they all delete at the same age. So I drag from here and search for random value node. I keep the minimum lifetime to 15 and maximum to 40. This will generate a random value based on the ID for each point. I change this to 35. Now I like to create another attribute based on this age. I call it Normalised Age. For that, I duplicate the store attribute node, call it nAge for Normalised Age. It's a float attribute. I will map the point's age to to 0 to 1 range. So duplicate the age node and search for map range node. Plug the maximum lifetime to from max socket. Keep the min and max at 0 and 1. Plug it to value. To view this, I duplicate this, set it to an age and view it with the points. You can see points closer to the mesh is darker, and towards the end of their lifetime they become white and get deleted. So why did I make this normalized age attribute? Because I can use this to adjust a lot of things over the lifespan of the points. For example, I make some space here and add another scale node. Plug the n age to scale. This way, at the start, points have almost zero motion, and towards the end, they receive the full strength of the motion. Right now, it is very linear, but I can plug a float curve node and adjust the curve to change its flow. Then I duplicate these nodes and put them here. I duplicate these again, put them here and plug a multiply node. I set the first value to this radius value and plug the output into radius. Now the points gradually becomes larger during its lifespan. Actually, I want the reverse of this. I want them to become smaller as they reach death. So I change the curve like this. Also add a bit of S-curve to it. Since they are outside of the simulation zone, we can see a real-time view of the results in the viewport. I increase the point count and reduce their radius. I am done with the simulation. Let's set some materials. Right now we can't see the points because I am in Eevee. We can't render points in Eevee. I switch to cycles. But if you want to render this in Eevee, plug an instance on points node to here. For instance, plug an icosphere. And for scale, plug a radius node to use the points radius. It's a bit slow compared to points, but if you are rendering an animation instead of still render, I recommend instances even in cycles because of some motion blur issues. I'll just use points for now. To add material to this, first I make two materials, one for the human mesh and the other for points. I call it particles. Use a set material node to add them to each geometry. I go to the shading workspace, switch to cycles render view. Here in the particles material, delete the principal node and add an emission node. Then add an attribute node and type our normalized age attribute name. This way I can bring attributes from the geometry nodes. By the way, if you are using instances, make sure to change this to instancer. Otherwise, it won't work. Now using this, I can change color of the particles over time. Drag from factor and add a color ramp node. Flip the color ramp and change the slider colors. I go for this blue tint for the particles. By the way, I am using AGX view transform for this. I change the look to medium high contrast. Plug this into the emission color and increase the strength. I adjust the colors a bit more. I go back to geometry nodes and reduce the point size even more. Now to the body material, I change the base color to complete white. Reduce the roughness a bit and bring the vertex group we made earlier using an attribute node. We call it 1. I plug a multiply to factor, set it to 2 and plug it to emission strength. For emission color, I change it to light blue. I add another color ramp and adjust the sliders like this and plug that into alpha. This will make those areas transparent. Now to the rest of the scene. I add a camera to the scene and hit Shift Alt 0 to align it to the view. Set the focal length to 35 and adjust the camera's position and angle. Then I add a plane and scale it up. Rotate it a bit to get one corner pointing away from the camera. This way I can get a better depth with a plane. Scale it a bit more and apply its scale. Back in the shader editor, I renamed the plane object to water. I want this surface to be very reflective. Create a material, I call it water. Reduce the roughness to almost 0. Again, set the base color to completely white. You can add transmission to the water material, but it doesn't seem important for this render. To deal with the background, I changed the shader type to world. Darken the background color a bit more. Add a texture coordinate node. Drag from window coordinates and search for mapping node. And follow it with a gradient texture. This will map the gradient texture to the camera window. I change the gradient type to spherical and adjust the mapping location to get something like this. Plug a color ramp and set the type to B-spline. Adjust the sliders to get a gradient like this on the horizon. Plug that to strength. Now I change the background color to match the scene. I also like to set this value to 1 in camera settings. It gives me a clear look at the camera view. I want the camera to focus right beneath this foot where it almost touches the water plane. I place the cursor there and add an empty. I call it focus. In the camera settings, I enable depth of field and select that empty as the focus object. Reduce the f-stop to 1 to get a very shallow focus. I set the ratio to 2. I reposition the camera a bit more. Then I add another plane. Rotate it and move it up a bit. In the edit mode, hit I to make an indent. Delete the inside faces, which leaves me with this frame. Then I add a solidify modifier for some thickness. Make sure to apply the scale of the object. Now for its material, back in the shader editor, I switch back to object shading. Make a new material. Delete the principal node and plug an emission node. Set its strength to 2 and color to blue. Then I freely rotate the frame to get a nice angle and a reflection on the water. After this, I want to add some ripples to the water surface. So in the edit mode, subdivide the plane few times. Then in the modifiers under deforms, I add wave modifier. Reduce the width for more waves. I adjust narrowness as well. For wave's start position, I pick the focus object. When I hit play, it has this animation. I can adjust settings regarding to that from here. I change the fall off to somewhere around 4.3. Add more waves. Right click and shade smooth the mesh. I add a subdivision surface for more resolution and put it above the wave modifier. Adjust the settings a bit more. I switch to camera view to get a better idea of the waves. I can set the transmission of the water material to 1 to get some refraction. But I keep the previous settings. And that's almost it. I render this and you can see it's a decent render, but I like to have some motion blur, so I switch to another slot, enable motion blur. I set the shutter to 1 and render again. And it took a lot more time than it should. More importantly, if you look at the render I got, there is an issue. I hit J to switch between the two renders, and you can see these weird lines glitches in the render. This can be very annoying. It is an issue in geometry nodes at the moment, and it can be fixed, but the reason for the issue can be unique to each setup. So I'll show you a trick that will probably fix it 8 out of 10 times. Just follow my steps for now because explaining it will require another separate video. But to give you a quick idea, what happens is that when we start deleting the points in the simulation, it readjusts the indexes of the existing points. Hence, the particle IDs, which depends on the index, also get changed. For motion blur, having a unique ID is important. So this process results in these glitches. We need a way to keep the ID consistent and unique to each point that spawns into the simulation, even if they get deleted after some time. So I make some space here. Put a set ID node, add an ID node, and plug an attribute statistic node. Plug this geometry into this. I want to get the current maximum value of the ID, and I add 1 to it using an add math node. Then I add an index node. This gives us the index of the points we are adding to the sim, and I add the current max ID value to it. The reason I add 1 here is because index starts with 0. Now set this as the new ID. This setup will keep the ID consistent and unique for each point, even if they get deleted. Make sure to refresh the simulation. Now if I render the same frame with motion blur, you see that issue is no longer there, and it renders faster as well. This trick will resolve this issue in most cases, but sometimes I found when rendering animation, this glitch again takes place in 1 or 2 frames. Using instances seems to fix that random frame glitch, so if we are rendering an animation, I recommend switching to instances, although it can be slow to process. But it does have better motion blur. Anyway, if you notice in one of my renders, I have a different color for the particle's reflection in the water. It's not a different sim or post-processing trick. It's done in Blender real time and not that complicated. All I did was, in the particles material, I used this light path node. This gives me a few options to separate particles and their reflection. I use its reflection ray with a color mix node to add 2 different colors for the particles and their reflection. You can see particles reflection on the water and the human mesh now has this orange tint. I can do this for other materials as well. But for this render, I keep the previous setup. So I have the final render. Let's go to Compositing workspace for the final touches. I enable use nodes. First, add a glare node. Set the quality to high, iterations to 4. Adjust the fade amount and set the mix to 1. I reduce the streaks to 2. Then I add a mix node to the rendered image. Plug the streak to it and set the blend type to add. Adjust the factor amount for the intensity. Duplicate the glare node and this time set it to fog glow. Decrease the threshold and increase the size. And just like before, add it to the setup. Then I add RGB curves node for some color grading. This is purely subjective, so I play with the curves to get something I like. After that, I add a lens distortion. Add some distortion and dispersion and check this fit box. Plug the final output into the composite node. And that's enough. for compositing. And that's how I made this abstract particle simulation render. But if you are rendering an animation, make sure to bake the simulation before rendering. So make sure to hit the like button, subscribe to the channel, we just changed the name. Hope you like it. And don't forget to share your thoughts below, and huge thanks to these amazing patrons. See you in the next one.